To describe a fundamental process like the annihilation of an electron with a positron and the creation of a muon and an antimuon, we see that we require interaction between the fields. And we saw that this could be naturally induced by requiring local gauge invariance. In that case, a Lagrangian needs to be invariant under local gauge transformation, where for a non-emission spin-off field, for instance, psi is changed by exponential I alpha psi, where alpha is a function of space-time. The problem is that the Dirac Lagrangian and also the Klein-Gordon Lagrangian for scalar fields are not local gauge invariant. This means that because of local gauge invariance, there is no such a thing as a spin 0 or spin 1/2 free field. In fact, we also showed that we can restore local gauge invariance by changing the covariant derivative into a gauge covariant derivative, which requires the introduction of a massless gauge vector field mu, and also kinetic energy corresponding to the energy cost when we change dynamically mu, and which is just given by the Maxwell Lagrangian. So we can't have a mass term for this vector field, because if we have a mass term, that will break gauge invariance. We also require that the gauge field transforms this way under gauge transformation in such a way that the final Lagrangian is gauge invariant. And we got this way the QED Lagrangian, in which appears an interaction between spinors, fields and vector fields in order to restore this gauge invariance. And that's nothing else but the interaction term of QED. This means that interaction is mediated by gauge vector field, and in the case of QED, this gauge vector field is the massless photon. So for instance, when we have a collision of two electrons, a possible interaction occurs via the exchange of the photon. But the problem is that such an interaction could also occur through another type of interaction called the weak interaction, and which is mediated by a massive gauge vector field. And of course, because Z0 is massive, it's actually about 100 times the mass of the proton, it explicitly breaks local gauge invariance by adding a mass term to the Lagrangian. So we still have some work to do in order to describe some fundamental processes like these. So we need to find a mechanism which will allow for the interaction to occur through a massive vector field without breaking local gauge invariance. And that will involve spontaneous symmetry breaking and also the Higgs mechanism.